In the endless reaches of the cosmos, mysteries abound, waiting to be uncovered by curious minds. Among the glittering tapestry of stars that light up our night sky, one in particular has fascinated observers for generations. Betelgeuse, the brilliant red giant that marks the shoulder of the mighty Orion. Often referred to as the shoulder of Orion, Betelgeuse has long drawn attention with its immense size and fiery glow. But now, something remarkable is unfolding in this distant corner of space, a phenomenon so extraordinary that it's captured the full attention of astronomers worldwide. The James Webb Space Telescope recently revealed that Betelgeuse has undergone a dramatic transformation. Its brightness has surged by an astonishing 250%. This surge has sparked intrigue and debate across the scientific community, as experts scramble to understand what might be behind this unprecedented change. Could this be the first sign that Betelgeuse is preparing for its grand finale, a spectacular supernova explosion? Such a dramatic increase in luminosity has challenged much of what we thought we understood about how massive stars live out their final chapters. Today we invite you to join us on a fascinating journey as we delve into the mysteries of Betelgeuse's unexpected flare-up and explore what it could mean for the future. Betelgeuse is no ordinary star. Even if you're not familiar with its name, you've likely noticed its reddish gleam in the night sky, perched on Orion's shoulder. To grasp the scale of this giant, if Betelgeuse replaced our Sun at the center of the solar system, its surface would reach far beyond Jupiter's orbit. This colossal supergiant has long been an object of fascination, not only because of its brilliance, but also because of how its brightness shifts in ways we can observe thanks to its relatively close proximity. Classified as a semi-regular variable star, Betelgeuse naturally varies in brightness as it approaches the end of its life. Its size and variability make it a perfect laboratory for astronomers studying the final stages of stellar evolution. What has especially caught scientists off guard in recent years are unusual changes in its light output, changes that defy simple explanation. One of these surprises came in 2020 during what became known as the Great Dimming, an event that led many to wonder if a supernova might be imminent. Since then, Betelgeuse's behavior has become even more curious. The star now appears to pulsate faster, and its brightness has reached levels not seen in living memory. Reports first surfaced in May 2023 when Betelbot, an automated observer of Betelgeuse, noted a 142% increase in brightness, which soon climbed past 150% and ultimately soared to the eye-popping 250% that has everyone talking. Astrophysicist Andrea Dupre confirmed that Betelgeuse has climbed the ranks to become the seventh brightest star in our night sky, up from its usual position at number 10. For those in the southern hemisphere, Betelgeuse is now an unmistakable beacon in the early evening sky, while observers in the northern hemisphere will soon enjoy similar views as winter approaches. Dr. Sarah Webb of Swinburne University in Australia highlights the rare opportunity Betelgeuse offers to study a massive star nearing the end of its life. A future supernova from Betelgeuse could dazzle the sky, possibly even visible during the day for weeks, casting eerie shadows at night, a cosmic event of a lifetime. But when might that happen? That remains the great question. Historically, Betelgeuse has brightened and dimmed in a predictable rhythm, completing a cycle roughly every 400 days. But now that rhythm seems to have quickened, with brightness variations occurring in cycles closer to 130 days. This shift began after the star ejected part of its outer layers in 2019, a violent outburst that continues to puzzle scientists. While this change in behavior has raised speculation, there's no definitive evidence that a supernova is near. Researchers, including Dri and her colleagues, estimate it could take years, possibly a decade or more, for Betelgeuse to return to its usual cycle. In the meantime, the star has exhibited subtle but telling shifts in both its light patterns and movement. Betelgeuse, massive and short-lived by stellar standards, is nearing the end of its brief existence, a mere 10 million years compared to our Sun's 5 billion-year age. When the star exhausts its nuclear fuel, its core will collapse and trigger an explosion so powerful it may briefly outshine entire galaxies. However, experts caution against premature excitement. Dr. Ogroa, a supernova researcher at the University of Portsmouth, reminds us that despite Betelgeuse's erratic behavior, predicting the exact moment of a supernova is incredibly difficult. It's likely that Betelgeuse still has thousands, even tens of thousands, of years left before it meets its explosive fate. Inside its core, Betelgeuse is now fusing helium into heavier elements like carbon, oxygen, and iron. These processes unfold over millennia, and once fusion ceases, the star's core will collapse, forming either a neutron star or a black hole. Recent studies propose that Betelgeuse may already be near the end of its carbon-burning phase, closer to collapse than once thought. If true, this would mean the star could explode within decades of exhausting its core carbon. But uncertainty remains. The carbon-burning phase itself might last hundreds or thousands of years, and new models continue to revise our estimates. If Betelgeuse were to go supernova in our lifetime, the spectacle would be unforgettable. Situated about 550 light-years away, its blast would outshine any star, rivaling the brightness of the moon and visible even during the day. Ancient cultures may have witnessed similar events, with records of second suns appearing in the sky. Before the main explosion, neutrinos, ghostly particles, would flood our detectors on Earth, giving us a few hours' notice. Then the night sky would light up with the fury of a dying star, a cosmic show unmatched by anything seen since humanity began gazing at the stars. Although we may not witness this in our lifetimes, Betelgeuse continues to teach us about the life and death of stars. Its recent brightening reminds us that the universe is full of surprises and that even the most familiar stars can still astonish us. When Betelgeuse finally reaches its spectacular end, the true spectacle will begin. Powerful bursts of high-energy light will break free from the collapsing star, creating a show visible to the naked eye and no telescope required. In mere days, Betelgeuse would outshine even Venus, becoming up to 100,000 times brighter than its usual glow. For about a week, it would dominate the night sky as the most brilliant object, casting noticeable shadows in the darkness and shining brightly enough to be seen during the day. The debris from this titanic blast could rival the brightness of a quarter or even half of a full moon, though concentrated into a single dazzling point. Imagine a cosmic event so radiant it eclipses Venus, the second brightest body in our night sky. Such a supernova would hold our gaze for months, with its brilliance lingering for nearly 100 days before gradually fading over many months more. During this time, astronomers would seize the opportunity to study the aftermath, uncovering new secrets of stellar death. And while its glow would slowly diminish, telescopes and binoculars would continue to reveal the fading remnants for years. Fortunately, Betelgeuse is distant enough that its violent demise poses no threat to life on Earth. Throughout history, the sudden appearance of such blazing stars often sparked fear and superstition. But today, the world would likely come together in awe and curiosity. Thanks to observatories like Hubble and countless backyard observers, we've gathered valuable data to piece together this mystery. Though some wondered if this signaled an imminent supernova, many experts advised caution. The dimming, they argued, could result from more ordinary causes, a cooler region on its surface or a veil of dust passing in front of it. In fact, researchers like Miguel Montages and his team at the Paris Observatory used high-resolution imaging from a Chilean telescope to investigate. Their observations revealed that the fading light was due to a combination of internal changes and a massive dust cloud formed from material ejected by the star. The images showed a distinct dark patch on Betelgeuse's southern hemisphere, evidence of the dust cloud born from a colossal surface outburst far more massive than anything seen from our Sun. This massive ejection likely started with a gas bubble inside the star that triggered the explosion. Though such outbursts are part of Betelgeuse's natural cycles, the scale of this event was unprecedented. And while the exact cause remains a puzzle, astronomers continue to monitor the star, hopeful that future observations will shed light on these rare cosmic events. What made this dimming so striking was how quickly and dramatically Betelgeuse faded, losing about 2/3 of its usual brightness, something visible even without instruments. Scientists estimate that the mass ejected in 2019 was about 400 billion times greater than a typical solar ejection. To put that in perspective, it would be like a person suddenly hurling away part of their body, an act that would throw their entire system out of balance. In the case of Betelgeuse, the loss disturbed its inner workings, setting off waves of turbulence and unusual pulsations. These chaotic movements are likely the reason for the star's current erratic brightness. The star is still stabilizing from that upheaval, much like a machine thrown off balance by a missing part. Observations of these events help astronomers better understand how red supergiants shed mass in their final stages before exploding. Astrophysicist Andrea Di and her team have studied Betelgeuse behavior closely, relying on data from the Hubble Space Telescope and NASA's solar observatories. Their work revealed unprecedented details about how a star's surface can violently eject mass, altering its appearance and behavior. This enormous convective plume disrupted Betelgeuse's normal rhythm. And while the star's outer layers are settling, its surface remains unsettled, a cosmic engine still regaining equilibrium. For millennia, Betelgeuse has fascinated humanity. Ancient observers from Roman poets to Aboriginal Australians noted its changing light. The star features prominently in mythology, from Orion's shoulder in Greek lore to Osiris in ancient Egyptian tradition. Even its name, rooted in Arabic, reminds us of its place as the giant's shoulder. Its color, too, may have changed over the centuries. Some ancient descriptions suggest it wasn't always as red as it appears today. Indigenous Australians have tracked Betelgeuse cycles for tens of thousands of years, their traditions recording the star's variability long before modern science took notice. These records remind us of the rich astronomical knowledge found in cultures around the world. In Western science, the idea that stars were unchanging persisted until the 16th century, when observations of variable stars like Mira challenged that belief. Betelgeuse was later labeled Alpha Orion, though we now know Rigel is brighter. Over time, studies of its brightness shifts helped give rise to astrophysics as a discipline. Today, Betelgeuse is classified as a semi-regular variable star with complex cycles that continue to surprise us. Despite all we've learned, Betelgeuse keeps many of its secrets. It's a vivid reminder of how much we still have to uncover about the cosmos. And one day, whether in a decade, 1,000 years, or longer, the star's inevitable supernova will light up our skies, offering a final, unforgettable display. But Betelgeuse's story is more than just a tale of an aging star on the verge of collapse. It's a window into the life cycle of the most massive stars in our galaxy. Stars like Betelgeuse are the cosmic forges that create and scatter the elements essential for life. When the star finally detonates in a supernova, it will seed space with carbon, oxygen, and heavier elements like iron, the building blocks of planets, plants, animals, and us. And that's why astronomers are so eager to witness such an event in real time. A nearby supernova would offer unparalleled scientific opportunities. Modern telescopes and detectors, both on Earth and in orbit, could capture the blast from every angle, across all wavelengths of light from radio waves to gamma rays. Neutrino detectors deep underground might catch the ghostly particles emitted at the instant the core collapses, providing clues about processes we've only theorized about until now. Gravitational wave observatories like LIGO and Virgo could detect ripples in spacetime itself, as Betelgeuse's core crumples into a neutron star, or possibly even a black hole. These measurements could help resolve some of the deepest mysteries of physics. How do massive stars die? What happens in those first moments of a supernova? And how do these colossal explosions shape the structure of galaxies? What's more, Betelgeuse's eventual explosion would connect us emotionally and culturally to the generations who came before us. Just as ancient civilizations marveled at new stars blazing into view, we too would pause to look up in wonder. News of the event would circle the globe, inspiring art, music, and storytelling as people grappled with the spectacle of a dying giant lighting our skies. While we wait for Betelgeuse's finale, astronomers continue to monitor the star closely. Networks of amateur astronomers contribute valuable observations, watching for subtle changes in brightness or unusual behavior. The worldwide collaboration between professionals and citizen scientists means that whenever the moment comes, humanity will be ready to record and learn from it. And Betelgeuse reminds us of our cosmic fragility and connectedness. We are, after all, stardust ourselves, our bodies formed from elements forged in ancient supernovae. When Betel explodes, it will be both an end and a beginning. The material it scatters into space will enrich future generations of stars and planets, continuing the great cosmic cycle. So tonight, if you step outside and look up at Orion's shoulder, take a moment to appreciate that faint red beacon. It's not just a star. It's a glimpse of the past, the present, and the future of our universe. And perhaps one day, you'll be among those who witness its transformation as Betelgeuse writes its final chapter in the sky. Thanks for joining us for this journey through the mysteries of Betelgeuse. Before you go, be sure to check out the next video on your screen for more fascinating cosmic discoveries.